Hi, I'm Tony Wong, and today I'll be talking about Mamba, which is a state space model that recently came out. It's basically a type of AI architecture for foundation models. So you probably all know or have heard about the transformer architecture, which was introduced in 2017 by this landmark paper, Attention is All You Need. And while transformer has enabled an entire wave of generative AI that we've seen in recent years, one of the big topics of discussion amongst the AI research community, amongst many, is transformer all you need to get to AGI? Essentially, is transformer all you need? So I wanted to provide a non-technical overview of Mamba because I think Mamba has some ways of addressing some of the challenges that we've seen with transformer models. In this discussion, I'm going to cover what is Mamba, and what are the benefits over transformer, and what does it mean for the rest of us? Why is this important? So let's dig in. Mamba, it was a paper that came out in December of 2023, so about 4 months ago, a paper by Albert Gu and Tri Dao. And we've already seen many variations on this architecture and many papers out recently, just in the last 3 or 4 months. And to understand why it's interesting in the first place, it's helpful to know some of the limits of transformer. In transformer, each token is treated the same, with each communication with other tokens done every single time, whereas that approach really impacts memory and latency. And latency actually increases quadratically as you get higher token lengths. As the context gets bigger, the model gets slower. I like to analogize to trying to get a rocket into space, and to be able to get that payload high enough into orbit, you need to add fuel, but that fuel adds to the payload, so you actually need to add more fuel to help that payload get into orbit. So you get into this sticky situation where the more you're adding, the more you need. Whereas in transformer, it has a harder time with longer context. So that's where you get some of the limits that we've seen around forget and hallucinations and slow latency and needing lots of compute. So those are some of the challenges. So Mamba tries to address some of these. And if you want to do more reading, I'd recommend this article that came out in The Gradient by Kola Aonrind called Mamba Explained. And it's actually a helpful way of just getting an overview as well. I could link to it in the notes. And basically in that piece, Kola talks about how there's really two important operations of a good machine learning architecture. It's one's communication between tokens, and the second is the computation within a token. In transformer is that the computation is that feed-forward layer where we use something called MLP, which stands for multi-layer perceptrons. And for communication, again, each token is communicating and establishes relationships with other tokens. That's using a mechanism called the multi-head attention mechanism. And so in the transformer block, it's all about improving performance by optimizing these two things. Whereas in Mamba, for computation, it still uses MLP, but basically replaces the attention mechanism with a state space model. And let's talk about what the benefits of doing that is. As I mentioned, with the longer sequences, transformer models seem to forget, or it starts hallucinating certain things. And the authors of the Mamba papers say that Mamba enjoys fast inference and linear scaling in sequence length. And when I first read that, I was like, linear scaling in technology, typically to really improve and 10x better and faster, you really want sublinear scaling. But then you realize that, as I mentioned earlier, with longer sequence lengths, the latency actually increases quadratically. So linearly is actually quite an improvement already. That's one of the big benefits of what the authors have shown and what we've seen in some of the other papers that have come out using Mamba. The other is not just requiring more compute, but also faster inference. Mamba basically selectively decides which information to keep and which information to discard. And basically says, hey, this is meaningful and this is not. Whereas transformer, it basically tries to remember everything. And then at runtime, it'll decide what is relevant and what is meaningful at that time. So one of the matrices in that paper I mentioned that was really helpful is this efficiency effectiveness. And one of the older architectures is something called RNNs, or recurrent neural networks. And RNNs, there's a previous generation, and there RNNs discard a lot of information. So there it's actually much more efficient, but not very effective. Whereas Transformer, it takes in all the information, so it's a lot more effective, but not as efficient. So what they argue in that article is that Mamba almost takes this Pareto optimal position between RNNs and Transformer because it's almost as efficient as RNNs, but also really does challenge Transformer on effectiveness. So I think there's actually an interesting point here around memory, because Transformers actually outperforms humans. And I think we've seen that in so many situations, because the human brain, we don't remember everything. We don't try to remember everything because we subconsciously store things that we think are meaningful. And whereas Transformer actually just takes in everything and then decides what's relevant at recall time. Mamba tends to be a little bit more human-like in that way. It really does selectively decide what to remember, like how we unconsciously decide what to store in our memories. So I thought that was really interesting. But one of the limitations I think more recently that has come out on Mamba is that in some of the needle and haystack tests where they test the ability to recall information, and they embed sort of Easter egg or hide relevant information in a long context window and to see if that particular model can find it. And what's interesting is that with transformers, and we've seen transformer models get bigger and bigger in terms of context length and context windows. For example, Gemini 1.5 now boasts a 1 million token context window. It's not clear whether Gemini is using Mamba, but certainly it's possible. And what we've seen with traditional, especially with the older transformer models, is that in needle and haystack tests and also just in practice, it tends to forget what's in the middle. It's in this way, it's actually the opposite of what we were just talking about. It's actually a little bit more human-like in that transformer models tend to have a better recall of what's going on in the beginning of the context window as well as at the end, and has a more difficult time figuring out what's in the middle. Whereas Mamba tends to forget what came first and generally is able to remember what's in the middle and in the end. And that's, for the most part, not how human psychology works. It tends to be more like transformer because there is a serial positioning effect. We will remember things that came first and last, first because of the primacy effect, and then last because of the recency effect. So if you think about a shopping list or something like that, I'll always have a hard time struggling with all the things that are in the middle. So I just thought that was a really interesting side note to how these architectures perform in relationship to human memory. And then finally, what does this mean for the rest of us, and why is this important? I think we follow this, and I follow this as an investor, because we want to know and see what people are building and what capabilities get unlocked. Because then we know whether if people are building something where there's technical risk, meaning, or technical scientific research risk, meaning they have to go out and unlock it, or whether it's largely a solved problem and now it's basically the challenge is putting together those underlying infrastructure pieces to actually deliver and package it into a product. That's why I think following this stuff is super interesting, just generally, but also what it means for the rest of us. I think with the larger context as well as lower latency, it enables a number of things. And let's talk about longer memory first. There's a number of applications now where you use these LLMs for chat and support. And a lot of what we're seeing is basically converting existing CAN response and FAQs and putting that into sort of an LLM, whether by using RAG or in context learning, and being able to have an LLM be able to answer queries and questions in support. Now, that we've seen that work really nicely, but we also know that the longer the context and the more frequent the interactions, it could forget some of the things that occurred earlier in that. So maybe for one session, it might be okay, or a few different sessions, but especially in the, call it loyalty services, right? You think about hotels and airlines and credit cards and other financial services where they're really building their business upon having you as their customer and rolling out new features, new products to retain that customer and upsell and cross-sell you into different products. That's very common in financial services, for example. And the interactions between you and the customer service and support, they really do want to have a long-term view over that relationship, which may be harder for existing LLMs. But so having a longer memory and be able to recall that is certainly one of the things that gets unlocked. By the way, there's a bunch of efforts, and it's not just Mamba, it's not just the architecture of the foundation model itself, but there's a number of different efforts to try to solve this. Everywhere from longer context windows, as I mentioned, to RAG and vector databases. We see a lot of people attacking this problem from multiple angles. Another example of that is personal assistants. A lot of people are building personal assistants. And one of the nice things about having a personal assistant is that it learns with you over time. But with a personal assistant, you don't have to remind that assistant, oh yeah, don't forget, like I want to sit on the aisle seat, or I'm allergic to these foods or something like that. Whereas with some of these virtual personal assistants that are LLM based, they may forget. So there's a bunch of things that get unlocked with longer memory. Another thing that gets unlocked is the ability to really go deep on certain domains, having domain expertise, models with domain expertise. And so here you can almost just feed a Mamba model just multiple textbooks, like all the math textbooks or chemistry textbooks. And I remember in law school where our professors, they would write these really long treatises, and they were like volumes, like encyclopedia volumes on just one topic. And there's no way for us to remember all that. And I don't even think the professor remembers all of that. But there would be a way to just put that all into a model to have the definitive model on criminal law or constitutional law, which might be a hard thing today because the context windows could get to certain sizes, but certainly not volumes and volumes. And speaking of dense data and lots of compute required is videos and movies. Not only generating video, but also reasoning in video. I think that could also be a really interesting opportunity. All the videos I think we've seen have been really short form, right? They last a few seconds in terms of generating a video. And then the challenge would be like, how do you make that consistent across different scenes and using the same character and setting and all that? So remembering and being able to also reason with longer context, hopefully is something that becomes easier with video. And then another one is code. Code, I think, is a really good example where a lot of developers use code, GitHub Copilot, and there's a lot of code models out there. And one of the things they report is just at some point the model forgets, and unless you remind them exactly what the context around that code is. And so it might be helpful to just pour in the entire code base as you're asking a model to help you. Magic.dev is a good example. They recently got a $100 million investment. And on their website itself, they say that transformers aren't the final architecture. And they say they have a multi-million token context window, which makes coding, I think, one of the really important and useful applications around longer context length. And then an example that the paper gives itself is around DNA sequences. So there are recent efforts to use foundation models for genomics because DNA is sort of likened to language with specific tokens and a finite vocabulary. But some of the sequences are really long and have been too long for transformer models. So some of these new areas get explored as we unlock some of the challenges that transformers have faced. I think that's one of the things that we're excited about and looking forward to as these new architectures come along, and very much in line with what we've seen with Mixture of Experts. A lot of the research that we've seen since then have been combining Transformer and Mamba. So it's not so much Mamba will replace Transformer, but there's been some really interesting hybrid projects that has had good results. So stick with us, and we'll continue to share what we're seeing and why it might be interesting and important for the rest of us. Thanks a lot.